Good morning, ladies and gentlemen. Thank you very much for joining us today. My name is Tomas Prokop, and I would like to share some information about the trends of dust emission monitoring in ambient air. Today, maybe I will start with introduction and give others time to join us. I hope that you can see the presentation now. So today I would like to say a few words about the Pallas company. Then I would like to share some information about the new trends in the dust emission monitoring, which came up during, let's say, last 1-2 years, especially related to the studies and last decade of the studies done on this field. Then I would like to share some opinions how it's possible to address those challenges and what are the requirements for the measurement technologies to be used. And of course, I would be more than happy to share how Pallas technology could help in such a situation. At the end, I would like to conclude and summarize. So about the Pallas, for those who never heard, Pallas is specialized in aerosol generation, characterization, and analysis since 1983. Our CEO is Dr. Max Weiss, and CSO is Michael Wolf, who is sitting in our branch in Shanghai. We are owned by Brockhaus Technologies since 2018, and all company management is running based on ISO 9001 since 2015, and we can be called as export-based company, as our export share is more than 60% last years. Pallas passed the transformation period during last few years, and we grown significantly, and we employ more than 100 employees in these days. Our headquarters are situated in Karlsruhe in Germany. As I noticed, Pallas is well known in the aerosol monitoring field, and we can be called leading developer thanks to all research and activities we done over the last almost 40 years. There is almost more than 30 patent applications internationally applied. Oops, sorry for that. Okay, apologies. So 30 patents worldwide applied, and our expertise is reflected by our participation in several committees in ISO, VDI, and others, where we are sitting and sharing the knowledge and experience. So we participate in the regulations and all the processes related. Our main customers been especially from research field first few decades, but then we focus in the industrial field, and also last 15 years we entered environmental monitoring field, as this is the topic why we met here today. Aerosol production is quite wide, and we are focused really from the bottom to the end. So since the aerosol generation through the dilution units, measurement spectrometers in different ranges, different fields, and we covering the filter testing application, process monitoring applications, air quality applications, and many others. Today we will focus on the air quality and fine dust monitoring. Maybe we will mention a little bit about the aerosol sensors and ultrafine particle monitoring. It's why I highlighted it here. Before we start, I would like to just really roughly summarize some information about the air quality framework in Europe, because it will be reflected during the webinar. So first, air quality directive is dated to 1996, which was revised in 2008, as you know, and since then, CAFE directive is valid. But this is coming to the end, let's say, and in these days, the European Commission is already revising the directive, and we can expect that new directive and new regulations coming soon, what will be also the topic of this webinar. This directive specifying reference and equivalent methods or even indicative methods which are related to the qualitative point of monitoring of different pollutants. We will be focused in particle matter monitoring, and with reflect to that, we can consider different standards applied. As you know, in the past, we have used EN 12341 and 14907 for PM10 and PM2.5, which been withdrawn. And since 2017, new regulation is in force. It's EN 16450. This is, of course, for continuous measurement. For the gravimetric sampling reference measurements, we still have EN 12341, which was updated in 2014. Main authority certification bodies in Europe, it's TÜV Germany, and of course many of you also know the certification body in UK, MCERT, which also verifying the technologies or instrumentations and measuring methods. In general, in regulatory monitoring applications, only type approved instruments in compliance with these directives and regulations could be used. During last, let's say, more than 1 year, since September 2021, when World Health Organization published a new air quality report with new air quality guidelines, after 15 years, the situation dramatically changed, and a lot of authorities and even the governments start to reflecting these new recommendations. And I believe this is a key point for our today discussion. And I would like to highlight several topics from this air quality report, or let's say air quality guidelines. First of all, with regard to the studies which were published over last decade or during whole 15 years, the WHO was evaluating the situation and seeing how dramatically the air pollution affecting the human health, and they adapted all their recommendation based on that. And they consider the situation as very dramatic, and they calling for urgent actions, where of course they're saying we should keep the air quality monitoring and management strategies ongoing, but they also saying it's necessary to expand them by new measures, new metrics need to be considered, and we need to be focused on a little bit different direction or extended direction. They specifically naming dominant pollutants like fine particles, PM2.5, as a critical point of monitoring to be deployed, because PM2.5 fraction been, let's say, not developed so well as, for example, PM10 or nitrogen dioxide monitoring. inner networks, and they simply calling for the equal measuring points to all those dominant air quality pollutants. Beside of that, they, as a part of PM2.5, highlighting the black carbon, which is not part of any regulatory requirements. It is part of some research recommendations and guidelines, right, like Actris from Tropos Institute, but it is not in the classic conventional regulatory framework. The same is valid for ultrafine particles. So WHO calling for the change of the valid legislation, and European Commission and several governments already begun this revision process, and the target is to adjust the regulations as close as possible to air quality guidelines published. WHO calling for the local approach, where we need to extend emission inventories and to be focused on the sources of air pollution, to be able to apply reduction measures, which been also approved by the governments with some time frame, as you know, till 2030 and 2050. So they simply highlighting everybody has a role to play, and they giving a tool how these initiatives, new initiatives, should be followed. If we're speaking about the trends related to these initiatives, we should firstly speak about particle matter measurements, which been done mainly by convention methods based on the mass concentration measurements. But all the studies published during last years clearly showing that particle number concentration and particle size distribution are same important as mass concentration, and could provide us much deeper insight to the health risk assessment. And of course, this is not respected in any regulation, and it's why WHO saying that if we want to get to suitable path, we need to go beyond the current legislation. And not only that, they even set very ambitious targets for convention mass concentrations of PM10 and PM2.5, which been set as 45 micrograms per cubic meter for 24-hour average PM10, or 15 microgram per cubic meter for PM2.5. Recently, earlier this month, or at the end of October, European Commission published their vision based on these recommendations, and estimated value of these air quality, ambient air quality standards in 2030. And those are even more ambitious. Those are, let's say, 20 micrograms per cubic meter for PM10 and 10 microgram per cubic meter for PM2.5. And I believe this is critical information, because this also affecting these conventional methods that we were using till now for mass concentration measurements, because as we know, it's also very well approved that the zero drifts of these conventionally used methods affecting the measurements. And if the limit value will be below 10 micrograms, then these conventional methods can be only hardly used in practice. The similar situation happening in stack emissions monitoring, when also the limit values coming down to 1, 2, 3, 5, 10 milligrams, and conventional methods also stop to be efficient enough. So what will happen is that some different approaches are needed. Of course, these conventional methods will be still used, but we need to think about the particle number monitoring also from the point of human health assessment, where this graph that I put on the slide showing how it is with the mass and the number. It's what you know very well, that the critical number concentrations are in a bottom range of the size spectrum, and it's where the most dangerous particles are situated. So these measurements will be critical also not only for human health assessment, but also for the possibility to identify and differentiate the sources of pollution and to answer different questions related, and to be able to do some reduction plans, apply some reduction plans. And with regard to that, it is more and more necessary to focus on the single particle measurements, not only during the sampling and laboratory studies, chemical compositions, but also during the classic real-time measurement of particle size distribution, which is the key information for the source apportionment, because it can give us unique profile, the pattern related to the source of pollution. As you know very well, there are different sources of pollutions in the air. It can be related to the natural sources like volcanic activities, sea salts, different let's say disasters like wildfires, and it can be also anthropogenic sources, which mostly are related to the combustion processes common in the industrial sites, or from the transportation, or home heating, home cooking, and these basic and common human activities. If we want to target any action measures and reduce the emissions related, we need to have real-time information about the situation, and we need to follow particle characterization to be able to see to which source actual situation is related to. And of course, this is very challenging topic, and first studies being published on this level, where machine learning algorithms in the near real time being used on these profiles related to the specific sources. It's still a long way to go, but first applications are already here, and the result seems promising. Of course, this is not possible as a standalone solution. This needs to be combined with existing data, with existing emission inventories, and only that way we can develop some unique tool which will help authorities to reduce the emissions around us. Of course, these measurements can be used for verification and quantification of the effectiveness of the measures, and this is the key point of the sustainability of these measures. Based on the management and let's say how to convey the right messages, it's necessary to consider multi-level approach for these strategies, because so far we've been relying on main authorities like governmental institutions, lawmakers and policymakers who been responsible for, let's say, national level of monitoring. Maybe in some countries, municipalities and decision makers being involved, and of course, a lot of researchers supporting these activities. But from the WHO point of view, this is just the national level, let's say, and it is necessary to go further. It is necessary to go beyond and focus on the regional and even local level of monitoring. And it's where industrial sources starts to be involved, not only from the point of view of stack emissions monitoring, which is regulated and which is, let's say, in the most of the countries working well, but it's related also on the ambient air monitoring around these sources. And it's also related to the communities and, let's say, a normal life of you or me, which reflect different activities, and during these measurements will be critical as well, because if we really should reduce the emissions in required level in the time frame set up, we need to have those information available. Without them, if we really base it on the governmental national level data only, it will not be possible to target these mitigation strategies correctly. And this is highlighted by WHO, and they're highlighting that this local approach is mandatory for the success. So how to step on for that approach? It's necessary to understand local conditions on site in a real time. And this is alpha of omega of this whole process. And many of officials already has some theory how and why the situation in their area is affected by different sources, and they just need support and help to identify these sources and evaluate the risks behind, to be able to create a momentum and advocate the actions which are needed. And these are applicable for different applications all around us, from the construction sites through the open mines, cement plants, quarries, energetic sector, or even the transportation networks, road or even air or sea transportation related. And these are all the main sources which share increasing, and it's necessary to apply the policies and actions which will investigate these sources, which will improve the emergency responses related to public health interventions, which allow decision makers to perform correct planning, especially like zoning or permitting building codes, or how to use the land after or during remediation and other such recultivation projects. It's related to the transportation, not only short term but long term. We can see it in the cities that somewhere it was dramatically underestimated. And it's related, of course, with future mobility. The project seems very promising, but some of them will suffer with a lot of issues, and without good planning, we will not be able to reach the targets. And all of those are very well recognized by several or main global players like the World Bank, United Nations, European Commission, and they are providing really huge investments to these projects related to the emission reduction. And it's possible to apply for these projects and receive the fundings and receive the support. This is the big message for you, that you are not alone, and nobody expecting that we would be doing it by ourselves. And these coordination activities are very important from my point of view. Air quality planning is key point of all of this, where during the air quality planning, the monitoring strategy is the key point, and it should be applied especially for the zones and agglomerations where air quality standards are exceeded. And to be able to answer required questions, we could be forced to combine several monitoring strategies together. So regulatory monitoring is not the only tool which could answer all the questions behind. We could be enforced to use non-regulatory monitoring approaches, or even low-cost hyper-local monitoring, which are so popular in these days, but bringing also certain risks and issues, which I will shortly mention later. Of course, the key point of every monitoring strategy is reporting and near real-to-time sharing of data with public to support the momentum discussed and support the decision-making process on time, and taking the activity or a measure needed on time, and be sure that the mitigation strategy is efficient. So from this investigation point of view, it's good to evaluate every, let's say, approach independently. And here it's example of such strategy, investigation strategy for particle matter quantitative and qualitative monitoring, which beginning with the location of monitoring hotspots, with the least amount of monitoring hotspots, if it's sufficient to use only, let's say, 1 or 2 devices, downwind, upwind, as it is now common concept in US based on the rule 1466 and others, or it is necessary to apply the border zone fence line monitoring strategy like perimeter monitoring. This really depends on each site, and it needs to be evaluated separately. Of course, it's also important to set up the monitoring periods needed. At some construction sites or others could be the working hours, the critical point of view, especially with respect to the health and safety requirements. But at most of them, I believe the 24/7 monitoring would be required to really receive comprehensive data sets to be evaluated. We need to be focused on the identification of pollution or polluting activities, and try to specify applicable mitigation measures with relation to the particulate matter and let's say dust control management. All of that should be supported with good management, with the database, and with all the approaches to really provide efficient air quality planning or air quality plan, which should ideally consider also the mitigation measures, where here is just example, because this is what I hear very often when I'm discussing it face-to-face with some of you. What could be our approaches, how we can consider the reduction of the pollution in the area. Here I found really nice example of the most one. So I hope it give you some ideas. Of course, every time we need to remember the cost efficiency, the best efficiency, and let's say how to keep the rights of public rights untouched, because the worst would be if these measures would affect somehow significantly quality of life of people. This would be very unhappy or not ideal solution. Yeah. So for air quality planning, I just would like to highlight again what I saw many times on site, where decision makers apply the mitigation strategy without knowledge about the possible efficiency. And this is very often huge waste of investment. Because if we apply the mitigation strategy wrong direction, or where the reduction potential is extremely low, then we don't have a chance to reach the targets, and it is the lost bottle before we start. So to know information about the, let's say, proportional level of anthropogenic emissions related, which are coming from the combustion processes, for example, or even the source identified emissions behind, it's very, very hard to apply these correctly, and in some cases it's more guessing than systematic approach. So please be careful about these to not reach some difficult situation on your side. For measurement technology selection, there are some basic recommendations which I would like to share with you, because again, in a field I saw many times some disappointments, but to be honest, not everyone playing fair play, and sometimes it's really necessary to measure twice before you cut. So I really recommend to verify your strategy and your decision with some expert, to be sure that you will not invest to the technology which is not applicable, or which is applicable with a lot of limitations, which is not suitable for your application, your specific needs. And this is why we're speaking in general about, let's say, 3 groups of such measurement technologies, which are, let's say, certified. This is what is used on national level, regulatory monitoring purposes, and what is very, let's say, good quality instruments and technologies, measurement methods, which providing very reliable data outputs, but which are very costly and not for every application feasible. From that purpose, we can see the second group of instruments on the market, which can be called non-regulatory or near reference, which are a little bit more achievable, but still could be, let's say, much higher in case we consider the complete network costs for some city or some bigger plant, for example. And it's why some of you already trying to combine it, and unfortunately also maybe substituting it completely with the lowest cost solution, what are local sensor, or how we call hyperlocal monitoring solutions. It really depends application to application, and I will highlight it later why I would recommend maybe the combination of those all as a best strategy to follow. Anyway, if you will be choosing any measurement technology, please remember several performance indicators which should be evaluated before you select it, especially like measurement range, drifting, or let's say accuracy of the quality of the data related, possibility to perform any quality assessment, assurance, and quality control if those tools are supported by the technology, what response time is provided, because this is why some of conventional and, let's say, reference methods are not ideal for these applications, because if you have only 24-hour data average, you are missing real situation and you are not able to evaluate it correctly. You are, let's say, a little bit blind to those short-term events which may be affecting the area most, but from those data you are not able to see it. So it's tough job. I don't want to get stuck on it, so let's go further, but don't forget it. It's hardware-based evaluation, but same importance is laying in the data management and data availability, and, let's say, how you as a user can access the data. Because if you would not have the access to the data and the necessary status information in a near real time, you would not be able to take action on time. If some traffic intelligence control systems would be involved, or if some dust suppression systems are involved, whatever, depending on the site, you every time need good quality information with status information of the device, and you need it in the real time, because there is nothing worse than data misinterpretation, because you eventually will invest to any technology, and if then these data will be misinterpreted, then you create the loss and damage more than if you would not be using any technology at all. And this is what needs to be respected, and this is what you need to be focused on. And please double check if technology you choose providing all these basic features, and even allowing some thresholds evaluation, maybe some reporting in the real time, alarms, warnings, and maybe even the remote management, which support the operation and maintenance of the technology. These are really critical points, same as the basic technical performance indicators. Here, I just would like to highlight that it's not about one component measurement. Today, we're speaking about particle matter monitoring, but it's about the conditions on site. The condition on site affecting situation a lot, and we need to do our best to understand this situation. Of course, we cannot be there all the time. We cannot have the cameras on and to see and watch it. It would be too time consuming. So we need to balance, take some compromise solutions. But what you can do at least is to measure the weather conditions on site, to be able to see if there is any precipitation, what is the wind speed, what is the wind direction, because at least those basic and quite cost feasible solution, let's say, provide you extensive understanding of the situation on site. And here on this figure, I just highlighting how the concentration of PM can dramatically change. This is specifically PM 2.5, can dramatically change when the wind direction change. So we can see it at the graph where the line is clearly indicated that at that time, what is, let's say, 12:30 or 12:40, the wind direction change and the concentration gone down from around, let's say, 180 to 30. I'm sorry, wrong data. From, let's say, 30 or 20 to 8 plus minus. So let's say a 50% reduction only by the wind direction change. So we can see that the wind brought some clean air, and the pollution which was related was overlooked thanks to that. And this is what we need to consider. And in case there is a precipitation, it's raining, of course, these data are good to know, because from nothing the particle matter concentration go down, air is cleaned, and you should understand why if you evaluating the situation on site. And how the Palace technology can support you with such approach and such challenges. We been focused on aerosol characterization for 30 years, and 15 years ago we decided to enter environmental monitoring. Very quickly we became a market leader, and our FIDAS 200 analyzers became one of the best solutions worldwide for the particle matter monitoring. And we receive certifications all over the world. And I would like to say this is, from my point of view, the best possible solution for regulatory monitoring available on the market. I think many of you knows that. There is no doubt about that. And I just want to say that this happened almost 10 years ago, and we definitely didn't sleep all those days, and we were working on improvement of this technology and bringing something extra and to support those challenges which we clearly seeing coming. And it's not like that we decided in September 2021 that because of WHO requirements we will develop some product. It's not like that. This is a result of 40 years developments and a lot of research behind, a lot of patents behind, as I already said. And for example, this year we introduced a compact version of FIDAS unit. It's called FIDAS Smart 100. It's a great approach and very unique product which don't have any alternative on the market, by the way. And from that point of view, and in combination with our another new product, AQGuard Smart series, we are able really to cover all the application needs, and we can provide you full traceability from the bottom to the top. So there cannot be any doubt later about the technology, about the relevant data, comprehensive data sets. Everything is compatible to each other, everything is traceable, and as I will speak later, we even providing QA, QC, real-time use tools, which is verifying quality of measurements. And those are just some of the highlights related to our technology, which can be applied in any of those regulatory, non-regulatory applications. Here is just a summary with some pictures how these products looks like. So I think many of you know FIDAS 200, which can be situated in the shelter or in the standalone housing box. You can see how our new FIDAS Smart 100, we just recently received certification based on EN 16450 as well, looks like. It is compact device. You can place it anywhere on the wall, on the mast. It's outdoor unit. It's tested to the different operation temperature range, and it's really stand-alone perfect solution to many applications. But still, as we discussed before, these regulatory monitoring approaches could be a little bit more challenging regarding the costs, and it's why we offering compact standalone AQGuard Smart solution, which is specially developed for the non-regulatory applications to reflect the cost effectiveness for these applications, which is highly needed. And this device has MCERT certification as indicative measurements based on the CAFE directive, and still is considered as high quality measurement for such applications. So this is for outdoor, and for indoor applications, we have the indoor version of FIDAS unit, which is called FIDAS Frog, an indoor unit of AQGuard, what is AQGuard. For all of these projects, products using the same technology, which was verified in ambient air, technical processes, healthcare, and research, and where we using several unique approaches, which are also patented, and which providing really unique features to users. And one of them is, for example, the stability and accuracy of our light scattering, which is related to linear calibration curve of our light source, what is the white LED polychromatic source with long lifetime, which is related to the reduced operation and maintenance costs. It's related to the T aperture profile, which allowing us to detect border zone errors or coincidence, which is related to the measurement range. Our instruments are famous regarding the huge measurement range, which you will see later. But this is really something unique, what is not common on the market. And sensitive photomultiplication unit, allowing us to tune the whole technology to extreme sensitivity. And I would like to highlight again that our measurement is based on the single measurement of each particle passing through. And we measuring size, and we measuring the number of all particles going through, and we are transferring the function to the particle mass concentration as well. And we are not doing it on the static approach as many others, but we developed dynamic algorithms where some of them are even patented, and it's allowing us to really do this transfer function extremely precisely. So now for the site contribution measurements, which are supported by our new product line, AQGuard Smart Series. As I noticed, it's MCERT certified in UK based on the indicative requirements, which is like near reference quality of data measurement, but it's providing simultaneously all the PM fractions, TSP, PM10, PM4, PM2.5, PM1, number concentration, particle size distribution, all the meteorological parameters, everything is included. And because of the source apportionment and many requests from our customers, we included also the electrochemical gas sensors for SO2, CO, SO2, NO2, CO, and ozone. And much more are coming. For now, we just introduced the solution with carbon dioxide measurement and total VOC measurements as well. It's a very robust and easy to operate solution with different mounting options. Here on the picture, you can see the delivery with the tripod installation, and the solution coming with all the data connectivity possibilities, which I will highlight in a minute. And it's possible to transfer data to our cloud, My Atmosphere, which also will be discussed. It's a very nice, compact, and let's say turnkey solution with attractive pricing set up to make its application to non-regulatory monitoring as easy as possible. It's plug and play device, so in real there is not too much you need to do after the delivery. It is coming with IP66 housing. All the connectors are of course protected and weatherproofed because it is outdoor compact solution, so it's not placed anywhere in the shelter. You're placing it directly outdoors. As I said, temperature, relative humidity, pressure monitoring are mandatory. Of course, heated sampling inlet is there and is needed to avoid any effect of the humidity in the air for the measurement itself. This is coming from the FIDAS and our famous IADS, Intelligent Air Drying System, which is again one of the best available. And we tested different operation conditions against the reference units, and even in tough conditions with very high humidity, it's working perfectly. As I noticed already, it can be extended by gas measurements, which allow the extra information evaluation to be able to identify the better sources of pollution behind. And of course, it's providing different accessories like a signal tower, which is even connectable through Wi-Fi. Wi-Fi hotspot is included in the device as well. There is also the 3G modem. You just place the SIM card in and you can be connected to our cloud, or it can be connected to new networks like LoRa wireless networks if available. Those are more coming in the cities or even industrial sites, and our device is LoRa compatible and ready. And new version of AQ-Guard coming even with GPS module, which is helping the evaluation of data, comparison of the different sites, especially in the networks developed. For those who like the display and the controlling device on site, there is a USB touch panel. And for those who like the wireless communication, you can control the device from your smartphone, your laptop, or even remotely from your office. Of course, a weather station with wind direction and wind speed measurements is also available as an accessory. Finally, several technical parameters where you can see that the measuring range for the mass measurement is even so high that coming to the maybe emission level of monitoring of particle matter, it's 100 milligrams per cubic meter. If we would speaking about the certified measuring range, it's 0 to 20,000 microgram per cubic meter. What clearly showing that we targeted this device to application with harsh conditions where really high concentration can be expected, and they maybe other technologies can suffer with a lot of limitations and a lot of biases. Our uncertainties are more or less good enough to be certified to EN 16450, but from the commercial point of view, we really targeted this device to be applicable to this middle range costly applications. So we keeping it as it is, but users can be sure that uncertainties are on the level of the certified devices. And I think this is one of the highest advantages. Size information is provided in 32 channels per decade. So because our size range is from 0.18 to 20 microns, we covering 2 decades. So total number of size channels is 64 size bins. So in each size channels, you receive the number of particles, and you can clearly see particle size distribution in very high resolution, what will allow you much more precise source apportionment evaluation. As I noticed before, we supporting all commonly used data interfaces, and our standard configuration coming with the 1 minute data output, which seems to be fully sufficient. But if necessary, we can of course change the configuration, same as it is with our FIDA series. Size of device, it's let's say a little bit bigger than A4 paper, Weight is about 6 kilograms, and operation conditions are tested from -20 to 50 Celsius, degrees of Celsius. And as already discussed, we are using some extensive gas sensors, where for SO2, NO2, CO, and ozone, we're using solid polymer electrochemical sensors, which not using any liquid electrolytes, what's supporting the lifetime, which is even at least 2 years, and which supporting also the stability, where we would say that plus minus 20 micrograms per cubic meter is the measurement which we can guarantee in case the calibration and QA/QC procedures are followed. For new version, we are using the NDIR and non-dispersive infrared CO2 sensor and PID total VOC sensor. All these sensors coming with the temperature and humidity compensation and onboard performance and status verification. So you can be sure that calibration data, which you can change on site by some calibration verification, comparison with reference unit, can be changed and are saved directly on the module of the gas sensor. So there is no change that after, for example, 2 years, when you would replace the sensor, there would be some risk of misinterpretation of the data with all calibration related to the other sensors. The device is connectable to 12 volt, but allowing us the power supply to be done from, let's say, accumulators, power banks, or modules, which could be also connected to the solar panels. So we already supplied solutions, let's say complete solutions, independently powered without grid connection. And one of the highest advantages, which I already noticed of all our technologies, is possibility to calibrate device in the field, not only on zero check with the HEPA filter supplied, but also on the target size channel, where we are using certified testing aerosol powder, Monodas 1500, which is even approved for FIDAS 200 TIFF approved and certified device. And through this method, you can only keep and verify the traceability of all our technologies. And this is why we supporting these hybrid networks and combination of the regulatory, non-regulatory, or even hyperlocal instrumentation. Shortly, I would like to just highlight at the end the ultrafine particle measurement version of our AQGuard 2000, which is based on the diffusion charging and measuring ultrafine particles below, what are particles below 100 nanometer. This diffusive charging is working from 10 nanometers up to 1 microns. And information like number concentration, mean diameter, and new metrics, lung deposited surface area, which is coming more and more as an evaluation criteria for ultrafines, is provided. The measurement itself is done from 1000 particles, and it's suitable even for high concentrations. So again, in case of some highly polluted, harsh conditions, this solution will be perfect and will not suffer with any limitations regarding the high concentrations. Here is just example how evaluation of the information from the ultrafine monitoring could look like, where you can see that data are compared to the, let's say, our reference environmental condensation particle counter, NVCPC 100, and the correlation was really good. And even the AQGuard, the Smart 2000, cannot provide particle size distribution. It's providing only the total sum of concentration of ultrafines in the measurement range. It still can be used very well to support evaluation of the site contribution and the situation related to the source of pollution. Here, just a summary of the versions of AQGuard Smart available. Version 1000, only dust monitoring. Version 1100 with standard gases. Version 1200 with the CO2 and total VOC sensor, and version 2000 with ultrafine particles monitoring. All the devices can be connected really from any device. In real, all our technologies do have computer inside, so whatever you want to connect and it's connectable to your network, be sure you can connect our device to as well. And we're providing different human interfaces, let's say, which can be used to just see the data or even to control the instrument. And of course, all the diagnostic and status information are shared through these channels. Extra, if you connect the device to internet, you can reach our cloud, which is called My Atmosphere. It's supportive for the most of our products, and it's online cloud platform which is developing every day because we're receiving more and more requests from our customers, and we're trying to follow any good idea behind. And basic features are interactive map where you can see all the stations connected to the network. The network could be private or public, depends how you need it. It's summarizing all the information. It can be compared one station, one location to other location to support your reporting by the tables, by the graphs. Exports are available in different formats. And of course, different averages available. And here you can see all the stations which are now connected to My Atmosphere. It's about, let's say, more than 3,000 stations connected. And I would like to go to conclusion because our 1 hour passed. And I just would like to repeat that all of this is needed just to better understand situation on site to be able to implement correct and efficient mitigation strategies. Unfortunately, there is lack of regulatory requirements, but this is highlighted by WHO, who motivating all of us to go beyond and focus on the real life needs and approaches on the local level. And we need to understand that conventional methods cannot answer this question fully, and some additional information like particle size distribution or others are key information to make health assessment or source apportionment, and all, of course, ideally in the near real time. From commercial point of view, I would like to highlight that you can choose fine dust or ultrafine particles monitoring version of AQGuard Smart. And still till end of this year, we do have running campaign where you can receive My Atmosphere license together with the device for 24 months free of charge. So this is a very interesting offer, and eventually we are ready to support you with the deliveries still till end of this year. So please feel free to contact us. Besides standard sales, we offering the short-term or long-term renting services, which are for these non-regulatory applications very common. And so if you would be interested in such service, please don't hesitate to contact us as well. You can find our instruments all around you, so just keep your eyes open, and we would be more than happy to receive photos of our instrument in the field. If you will have them, please feel free to join us on LinkedIn or other social media like Twitter, Facebook, or elsewhere, and share the photos with us. And if you please have any questions, use the chat, and I will do my best to answer your questions now. Thank you very much for participation of this webinar, and I would love to see you next time. Have a good day. Bye-bye. I have a question here. Is it possible to position AQGuard Smart as an indicative station? We are not targeting market of indicative stations, if you mean it as a low-cost sensors, because those are available for a few hundreds of dollars, as I noticed, and suffering with a lot of biases. Such discussion would be maybe for another 1 hour. But what I would like to highlight is that we are happy to see that anybody using any air quality monitoring technology, we are just saying they need to be careful regarding data quality and these biases, which are related especially with low-cost solutions. And to do so, it's why we recommend hybrid solution in combination with our AQGuard Smart or even FIDAS Smart or FIDAS 200. The point is to create the chain, traceability chain, which allow you to operate and verify your data, let's say every day. You need to be sure that you're receiving data in a quality you need it, because you will use it for measures and actions which will cost you for sure something, and you need to be sure that these activities are targeted properly and that you're not wasting your resources based on some false reading or data misinterpretation. So ideally, I would really recommend you to consider AQGuard within your network of hyperlocal measurements as a near reference point, and then maybe FIDAS Smart 100 as a transfer standard, or different similar QA/QC procedure to be defined. I hope this satisfy your question. Of course, please feel free to place it. I'm trying to read others, but unfortunately there's something wrong. Sorry for that. Okay, I got it. Okay, here I am. Okay, someone don't hear me. Okay, I hope it wasn't the whole hour that I would be speaking to no one. Okay, another question. No, another question. Just thank you. So thank you, guys. A pleasure to see you. I hope you receive information you needed, and see you next time.